Ravi Desai, your instructor for the video series of data mining and business intelligence. Today's our topic is prediction methods. So let's get started. Prediction refers to the output of an algorithm after it has been trained on a historical data set and applied to new data when forecasting the likelihood of a particular outcome, such as weather prediction. Prediction in data mining is to identify data points purely on the description of another related data values. It is not necessarily related to the future events, but the used variables are unknown. Prediction derives the relationship between a thing you know and a thing you need to predict for future reference. Generally, regression analysis is used for prediction. So let's understand what is regression. Regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. Regression analysis provides detailed insight that can be applied to further improve product and services. Regression analysis is mainly used for two different purposes. First, regression analysis is widely used for prediction and forecasting, where its use has substantial overlap with the field of machine learning. And the second application, in some situations, regression analysis can be used to infer causal relationships between the independent and dependent variables. Importantly, regression by themselves only reveal relationships between a dependent variable and a collection of independent variables in a fixed data set. In order to understand regression analysis fully, it is necessary to comprehend these two terms, which is dependent variable and independent variable. Well, dependent variable is the main factor that you are trying to understand or trying to predict, whereas independent variable are the factors that you hypothesize have an impact on the dependent variable. In simple terms, regression is a data mining function that predicts a number of values like age, weight, distance, temperature, income, or sales attributes that can be predicted using regression techniques. For example, a regression model could be used to predict children's height given their age, weight, and other factors. A regression task begins with a data set in which the target values are known. For example, a regression model that predicts children's height could be developed based on observed data for many children over a period of time. The data might track age, height, weight, developmental milestones, family history, and etc. In this example, height would be the target, the other attributes would be the predictors, and the data for each child would constitute a case. Regression models are tested by computing various statistics that measures the difference between the predicted values and expected values. It is required to understand the mathematics used in regression analysis to develop quality regression models for data mining. The goal of regression analysis is to determine the value of parameters for a function that cause the function to fit based in a set of data observation that we provides. So let's discuss the methods of prediction. As you can see in this figure, there are three different methods that are used for prediction, which are linear regression, nonlinear regression, and logistic regression. So let's start with the linear regression. Linear regression attempts to model the relationship between two variables by fitting a linear equation to observed data. One variable is considered to be an exploratory variable and the other is considered to be a dependent variable. In linear regression, the relationships are modeled using linear predictive functions whose unknown model parameters are estimated from the data. Such models are called linear models. The very simplest case of a single scalar predictor variable x and a single scalar response variable y is known as simple linear regression. A linear regression line has an equation of the form y is equal to b1x plus b0, where x is the exploratory variable and y is the dependent variable, where the slope of the line is b1 and b0 is the intercept. What is intercept? Intercept is the value of y when x is equal to 0. The extension to multiple predictor variable is known as multiple linear regression, which is also called as multivariable linear regression. Nearly all real-world regression models involve multiple predictors, and basic descriptions of their linear regression are often phrased in terms of the multiple regression model. It uses two or more independent variables to predict the outcome, and a single continuous dependent variables like y is equal to b0 plus b1x1 plus b2x2 plus b3x3 and plus bnxn plus u, where y is equal to dependent variable, or we can say response variable, x1, x2 up to xn are the independent variable or the predictors, where u is equal to random error, and b0, b1, b2 up to bn are the regression coefficients. Now let's discuss the nonlinear regression. Nonlinear regression is a regression in which the dependent variables are modeled as a nonlinear function of model parameters and one or more independent variables. Often, the relationship between x and y cannot be approximated with a straight line or curve. For that, nonlinear regression technique may be used. That can be seen in this given figure. Now let's understand the logistic regression. Logistic regression is the appropriate regression analysis to conduct when the dependent variable is binary. Like all regression analysis, the logistic regression is a predictive analysis. Logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal, ordinal, interval, or ratio level independent variables. Logistic regression models the probabilities for classification problems with two possible outcomes. It's an extension of the linear regression model for classification problems. In statistics, the logistic model is used to model the probability of a certain class or event existing, such as pass or fail, win or lose, alive or dead, or healthy and sick. This can be extended to model several classes of event, such as determining whether an image contains a cat, a dog, a lion, etc. Each object being detected in the image would be assigned a probability between 0 and 1 with a sum of 1. Logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable. Logistic regression is one of the statistical techniques in machine learning used to form prediction models. It is one of the most popular classification algorithms, mostly used for binary classification problems. So that's it all about the logistic regression. So in today's session, we discuss what is prediction. Prediction refers to the output of an algorithm after it has been trained on a historical data set and applied to new data when forecasting in likelihood of a particular outcome, such as weather prediction. Then we also have a discussion about regression. Regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. Regression analysis provides detailed insight that can be applied to further improve the product and services. Apart from this, we also have a look at the different methods for prediction, like linear regression, nonlinear regression, and logistic regression. So that's it for this lecture. Thank you.